question up here. I'm asking, are they parallel? So I'm giving you two different lines that I'm describing different ways, and then I'm giving you a plane, and I want to know, is this line parallel to this line? Is this line parallel to the plane? And is this line parallel to the plane? I'm going to suggest that you pause the video and try to answer those questions, and then tune back in and we'll work through them together. Welcome back. That was a very low-tech version of pausing the video. Okay, so for each of these things, there's a vector that I can associate with the object that has something to do with its direction. So for the line, that's going to be the direction vector for the line. Now here, these equations are almost, but not quite, the symmetric equations for the lines. Notice here I've got x minus a number divided by a number, y plus a number divided by a number. Those are in standard form for the symmetric equations. But here, I've got 2 minus z. I don't have just one copy of z, I've got negative 1 copy of z. So for this one, I would need to factor out that negative 1 to write that as negative z minus 2 over 5. And then I'm going to bump that negative to the bottom. So that's z minus 2 over negative 5. Now, once I have that, the numbers that are in the denominator are the components of the direction vector. So I'm just going to write v1 here as the direction vector for line 1, and that's 3, 4, negative 5. Now, line 2 was given in vector form, starting point plus t times direction vector. So I've got my direction vector right there. It's a little easier to spot that one. So that's negative 6, negative 8, 10. Now, if you just check if they're the same, you would say no. But what I'm looking for is, are these direction vectors parallel? And notice this is just negative 2 copies of v1. So the two lines are therefore parallel to each other. Now, one thing that's nice is that means they're going to have the same relationship to the plane. Either they're both parallel to the plane or neither one is parallel to the plane. So let's check. With the plane, the vector that I'm concerned with is the normal vector. And this is almost in standard form, but I've got x's, y's, and z's all together on the same side of the equation. So I can pick out the normal by just picking out the coefficients in front of x and y and z. Now I need to be careful because the relationship that this has to the plane is not that it is parallel to the plane, but that it is normal to the plane. So anything that's going to be parallel to the plane is going to have to be perpendicular to this vector. So I'm not looking for, are my direction vectors a multiple of this? I'm looking for what's the dot product. And since I already know these two vectors, and therefore the lines that go with them, were parallel to each other, I know that I only need to check with one of them. So I'm just going to check v1 dotted with n. If that is 0, since these were non-zero vectors, if that's 0, that means that they're perpendicular to each other. And if the direction vector for a line is perpendicular to a plane's normal, that's going to mean that the line is parallel to the plane. Because remember, if here's my plane and here's my normal, being perpendicular to the normal means being parallel to the plane. Okay, so let's check that. So that's 3, 4, negative 5, and we're dotting that with 2, 1, 2. So let's see, that's going to be 6 plus 4 minus 10, that is 0. So yes, both lines are parallel to the plane. So the two lines were parallel, and the plane was parallel, but for slightly different reasons. Now, if I put on a quiz or an exam, are these things parallel, you do not have a 50-50 chance of getting full credit. You might have a 50-50 chance of getting the right answer, but in order to get any credit, you would need to justify your answer. So the lines were parallel because their direction vectors were parallel. They were multiples of each other. And both were parallel to the plane because they were orthogonal in the sense of perpendicular to the plane's normal vector.